Hello everyone, how are you all today? I welcome you all to our YouTube channel where I will not just teach you mathematics, I will help you truly understand it. So let's get started. Now before I start, I should must answer that who should watch this video. So students from class 6th to 10th can watch this video, and if you are someone who has just been promoted to class 9th or 10th, then this is a must watch video for you people. So students, we have been using numbers since our childhood to solve math problem and even handling real life situation. But have you ever stopped to think, do you really understand numbers? Now some of you might feel confident while others might find them confusing. Either way, stick with me till the end of this video because by the time we are done, you will see numbers in whole new way. These are the topics that we will be covering in this video, so please have a look. Let's start with natural numbers. So students, when we were young, the very first thing that we were taught in mathematics was counting. And it was later on in class 4th or 5th that we were introduced with a term known as natural numbers. So what are natural numbers? So natural numbers are the counting numbers that we study in our junior classes. It is the same counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Also, natural number starts with 1 and goes to infinity. And what is infinity? So infinity is something that never ends. It is always bigger than anything you can think of. So imagine if you are counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you will never have to stop. You can keep on counting and counting, and the natural number will never end. And you can keep on counting forever. So that is infinity, something that never ends. So if natural number goes to infinity, that means natural number will also never end. Also, the example of natural numbers are 1, 2, 3, 4, 5, 6 that you already know. And these three dots represent something that goes on forever. So this pattern continues. So these three dots represent anything that's continue forever. So natural numbers do not include fraction and decimal numbers. So this is something that you need to remember, that natural number will not include fraction or decimal numbers. Example, 1 by 2 and 2.9 are not natural numbers. Okay, so this is everything that you need to know about natural numbers. Now let's learn about whole numbers. So I want you to imagine that you have 10 chocolates and you ate all of them. Now if I ask you how many chocolates do you have now? So what will you say? So the most of you will say that you have 0 chocolates now. So it means that you know that when you have nothing, you say that I have 0. Okay? So this can be interpreted as, to describe the number of objects in a collection with no objects, we use 0 to show nothing. Okay, so I think this should be clear to you. Now the counting numbers or natural numbers along with 0 form whole numbers. Okay, so if you have all the natural numbers and you add 0, then you get what? You get whole number. So just like natural numbers, um, the whole number starts with 0 and goes to infinity. If you remember, then I told you that natural number starts with 1, but the whole number starts with 0. Okay, now just like natural numbers, whole number also do not include fraction and decimal numbers. For example, 0.7 and 3 by 2 is not a whole number. Okay, now if I ask you to give me some example of whole number, then you can say that 0, 1, 2, 3, 4 are whole numbers. Okay, now, and remember that all the natural numbers are whole number, but not all whole numbers are natural number. For example, 0 is a whole number but not natural number, whereas you can take any natural number and you will find out that all the natural numbers are also the whole numbers. So I want you to remember this as well. Okay, so this is everything about whole number, but I want you to tell something more about whole number. So for that, I want you to imagine that we have a circle. Okay, and we will represent this circle by w. Okay, now in this circle we have a number 0. Okay, 0, and then in this circle we have another circle, and I will name this circle as n. Okay, now in this n we have all the natural numbers 1, 2, 3, 4, and so on. Okay, so in the circle n we have all the natural number, whereas in the circle w we have 0 plus this circle, the circle n. So this circle can be said that this bigger circle can be said that this is the circle of whole number, because it has 0 and all the natural numbers. So this is how you can visualize whole numbers. Okay, so now let's move to the integers. Integers. So we use negative numbers to show numbers lesser than 0. Now some of you may wonder that what is the need of negative numbers? Okay, we do not need negative numbers. It's not like when we go to a shop, we ask the shopkeeper to give us minus 10 chocolates. Okay, so you may think like that. So in order to clear your this doubt, I want you to imagine that you have a bank account. Okay, so imagine that you have a bank account, and this account has some special privilege. And what is that privilege? That privilege is that you can spend from this account even when you don't have money in the account. So even if you have 0 rupees in the account, you can spend from this using this account. You can make transactions. Okay, now suppose you went to a shop and you want to buy an item, and that item cost 105 rupees, but you have only 100 rupees in your account, and you know that you have the special privilege in your account. So you will give your card to the shopkeeper and ask him to make the transaction. And since your account has special privilege, the bank will also allow the transaction. And if you do not have that privilege, the special privilege, this transaction wouldn't have went through. Okay, this transaction would have been declined, but since you have the special privilege, you can make this transaction now. Okay, so you will be able to buy that item. Okay, now if I ask you how much money do you have in your account? Okay, so now since you have bought that item that cost 105 rupees, and you only had 100 rupees in your account, and now I am asking you how much money do you have in your account. So what will you say? So most of you will think that zero is the we have 0 rupees in our account. But students, this is not the correct answer. Okay, 0 means you have nothing in your account. Okay, you have no money in your account, but you know that you do not have 0 rupees in your account. In fact, you owe bank 10 rupees. It means you are in debt, not 10, 5. So it means you are in debt and you need to pay 5 rupees to your bank. Okay, so now you will say that yeah, we owe bank 5 rupees. So if I ask you to give me a number that describes this particular situation, so how will you do it? Will you able to answer this without integers? No, you won't be able to answer. You will need negative numbers. So you can say that I have minus 5 rupees in my account. Okay, and this would clarify that you owe bank 5 rupees. Okay, so now you know that why you need negative numbers, and this is just one example. In our day-to-day life, we encounter many problems in which we need negative numbers. Okay, so this was just one example. Okay, you can take various other examples as well. Okay, so now you know why you need negative numbers. Now all the negative numbers, not all the negative numbers combined with whole numbers, we obtained a new collection of numbers, and this new collection of numbers is known as integers. So if you put negative numbers and plus whole numbers, then you will get a new collection, and this collection is known as integers. Okay, now here are few examples of integers. So you can see that all of these numbers are whole number 0, 1, 2, 3, 4, and so on. And on the left side we have negative numbers minus 1, minus 2, minus 3, minus 4, and so on. Okay, now if I want to represent all these number on a number line, so this is a number line. Okay, so if I represent these numbers on a number line, so you can say that, so you can see that this is the positive side of the number line, and this is the negative side of the number line. Okay, now on positive side here I have written positive infinity, and this means that this number line continues until positive infinity, and similarly on the negative side also negative infinity. Okay, now in center we have 0, and on the right side I have positive numbers, and on the left side I have negative numbers. Now if I ask you, out of 1 and 3, okay, so out of 1 and 3 which one is bigger? So you already know that 3 is bigger than 1. Similarly, 100 is bigger than 1, okay, so you know that, okay. So any number in general, I can say that any number which lies on the right of the another number, okay, since 4 lies on the right of 3, so 4 is bigger than 3, so I can say that any number which lies right on the right side on the number line of the another number, it means that number is bigger than the another number. So if you want to compare two numbers, you just have to make a number line and you have to represent those places of those numbers, and if you can see that which number will lie on the right side and that number is bigger. And same thing happens on the negative side as well, okay. So if I ask you which one is bigger, -2 or -1, so for that what you will do, you will make a number line and represent -2 and -1 on the number line, and you will see that -1 lies on the right of -2 on number line, and it means -1 is bigger than -2. Similarly, any number which lies on the right side on the number line of the another number is always bigger than the other number, okay. So this is something that you need to remember, always need to remember, okay. And in on the negative side, the bigger the number, the smaller it becomes. For example, 4 is bigger than 3, so -4 is less than -3, okay. So this is it. Now 0 is neither positive nor negative. Yes, if I ask you, is 0 positive or negative, so most of you will say that 0 is positive, but I want to say that I would like to clarify that 0 is neither positive nor negative. Also, fractions and decimals, just like natural numbers and whole numbers, fraction and decimals numbers are not allowed in integers as well, okay. So we saw that in natural numbers and whole numbers we do not include fractions and whole numbers, fractions and not whole numbers, fractions and decimal numbers. Similarly, in integers as well, we do not include fraction numbers and integers, okay. So for example, -1.9, 7 by 3, 2.5, and -8 by 7, etc. are not integer. And remember that I am telling you that these are not integers. Don't assume that these are integers, okay. These are not integers, okay. Now, since you know that decimal numbers and fraction numbers are not allowed in integers, and because of this fact, -1 is the largest integer, okay. So you can see that -1 is the integer, largest integer, because it lies largest negative integer, okay. Remember, largest negative integer. This is due to the fact that on the right side of -5, you want find any integer which lies on the right side of the -1 and also a negative integer, okay. So none of the negative integer lies on the right side of the -1 on the number line, and that's why this makes the -1 largest negative integer, okay. Now 1 is the smallest positive integer, okay. So you already know that 1 is the smallest positive integer because 0 is neither positive nor negative, and due to this 1 is the smallest positive integer, okay. Now if I want to represent all this information using a picture, okay, so what I want to do is, the all the numbers that I have taught you so far, natural numbers, whole numbers, and integer, and I want to represent them using a picture, so I can do this by this method. What I will do is I will make a circle, and inside that circle I will make another circle, and inside that circle, okay, I will write W. W means whole number, and since this is W, it would include 0 plus the circle of natural number, that is 1, 2, 3, dot dot dot. So natural number, circle of whole number will include circle of natural number plus 0, okay. And in integer, the circle of integer will include all the negative numbers, okay. So this is it, dot dot dot. So all the negative in the circle of integers we have negative numbers, all negative numbers, and then the circle of whole number, and whereas circle of whole numbers include 0 plus circle of natural number, and circle of natural number includes 1, 2, 3, all the counting numbers, okay. So this is how I can represent all the information using just a single picture, okay. So this is the basic idea about integers, and this is not everything about integers. Okay, so if you want to learn more about integers, you can write down in comment section. You can write in comments, and I will make a series of videos in which I will explain more about integers, because there is a lot to cover about integers and everything cannot be covered in this video, because in this video I just want to give a brief introduction to all the numbers. Okay, so I hope you understand it. And so yeah, just write in the comments and I will make a very easy explanation for integers as well. Okay, so for now we are done with integers. Now let's learn about another type of number, which is known as rational number. Okay, so what are rational numbers? So any number that can be represented in the form of p by q, where p and q are integers and q is not equal to 0, is called a rational number. Okay, so if you can represent a number in the form of p by q, where p and q should be integers and q should not be equal to 0, then you can say that that number is a rational number. Now here are few examples of rational number. Okay, so you can see that 7 by 9, I can this 7 by 9 is in the form of p by q, where both 7 and 9 are integers. Similarly, minus 3 by 8, minus 4 by 9, and also 2 by minus 5, all of these numbers are rational numbers. Okay, now all integers are rational numbers. Yes, this is a very important point that you should know, that all integers are rational number. And why? Because we can write 1 in the denominator of every integer, and this will not affect the value of the integers. Okay, so you can, for example, you can see that minus 2 is an integer. Okay, and I can write it like minus 2 by 1. Okay, this will not affect the value of minus 2. Both minus 2 and minus 2 by 1 are both equal. Now if you will observe carefully, then I am able to represent minus 2 in the form of p by q. Okay, and if I am able to represent a number in the form of p by q, where p and q, p is minus 2 and q is 1, so it means both p and q are integers, and also q is not equal to 0. It means what? It means minus 2 is an rational number. Okay, similarly I can write 3 is equals to 3 by 1. Again, minus 101 is equals to minus 100 by 1. So all of these integers are rational number. In fact, every integer is a rational number, because you can write it in the form of p by q. Okay, now you may have a doubt that are decimal numbers also rational number, or are they not? So for that, I would like to tell you that we know that all the fraction can be converted into decimal number. Yes, you have already done that. You have converted fraction to decimal form in your previous classes. Okay, but the reverse is not true. For example, we are not able to convert every decimal numbers in the fraction form. We can convert every fraction in the decimal form, but we cannot convert every decimal number in the fraction form. And only those decimal numbers which can be converted into fraction form are known as rational numbers. Okay, so only those decimal numbers that can be are rational numbers which can be converted to rational form, or you can say fraction form. So if a decimal number can be converted to p by q form, where p and q are integers and q is not equal to 0, then you can say that that decimal number is a rational number. Now this would be more clear if we look at the type of the decimal number. Yes, decimal numbers also have types. Okay, so if we look at the type of the decimal number, this would be more clear. Okay, so let's look at the type of the decimal numbers. Okay, so decimal numbers are categorized in three types. So first one is terminating, and the second one is non-terminating but repeating, and third one is non-terminating non-repeating. Okay, now you may wonder what are these names. Okay, so these are nothing new. You have already studied about them, but you have not known their names so far. Now we have introduced a new term for these numbers. Okay, so let me give you an example. So if I write the fraction 3 by 2, okay, now if I ask you to convert it into decimal form, you can say, yeah, so what you will do, you will divide 3 by 2. You have to convert 3 by 2 it into decimal form. Okay, so I will divide what? 3 by 2. So I can see that 2 times 1 is 2 and the remainder will be 1. Again, I can write point in the question, and then I will take 0 here and this will become 10, and so 5 times 10 and remainder is 0. So you can see that if I divide 3 by 2, 3 is not exactly divisible by 2, but if I take decimal in the question and I divide further, then I can see that at some point I will get remainder what? I will get remainder 0. So the division terminates. Okay, when you get remainder 0, your division terminates and you cannot divide any further, even if you have decimal in the question. Okay, because your remainder became 0. Your division is only possible when the remainder is not 0, and since the remainder is a 0 here, we cannot divide any further and division has terminated. And in this case we will say that 3 by 2 is a 3 by 2 is equals to 1.5, and this 1.5 is a terminating decimal, because when we find out this 1.5 we saw that the division terminated. Okay, so this 3 by 2 is a terminating decimal. Okay, now so this is what terminating. And any number, if you are dividing a fraction and you find out that the division terminates after certain number, then you will say that that decimal number is a terminating decimal number. Okay, now let's look at what is non-terminating but repeating decimal numbers. Okay, so this is also something that you have already encountered in your previous classes. For example, if I ask you to divide 1 by 3, if I ask you to convert 1 by 3 into fraction form, so what you will do, you will divide 1 by 3, and now you know that 1 is not divisible by 3, 1 is smaller than 3. So what you will do, you will take 0 point and this will become 10. Now 3 times 3 is what? 9. Remainder is 1. Again you will take 1 0 and this will become 10. Again 3 times 3 is 9, and again the remainder is 1. So you can see that remainder is not becoming 0, and again every time the remainder is 1 and you take 1 0 from the you take 1 0 because of this decimal in the question, and then you divide and again you get remainder 1. So this keeps on repeating, and no many how many times you divide, this will keep on happening. You will keep on getting remainder 1 and 1, and you will never get remainder 0. And in such case you will see that the quotient in question, if you observe the quotient, you will find out that the 3 is being repeated every time you are dividing, you are getting 3 in the quotient. So I can write it like this: 1 by 3 is equals to 0.333, and dot dot dot. This 3 dots means this 3 is being repeated infinitely many times. Every time I divide, I will get 3. And such decimal numbers whose where division does not terminates are known as non-terminating. Okay, but you can see that the division itself is not terminating, but the numbers in the quotient are repeating. Okay, so after the decimal, numbers are being repeated, and that is why it is known as non-terminating but repeating decimal number. Okay, so this should be clear to you as well. Now we will move to another form, which is non-terminating non-repeating decimal form. Okay, so both of these form, terminating and non-terminating but repeating decimal form, you have already encountered them in your previous classes. Okay, and in this class, in class 9, the a specific term is introduced for these two types of decimal numbers. Okay, so this is nothing new. Now non-terminating non-repeating decimal, so what are these? So for example, if I write a decimal number, see 1.01001 triple 01, then 4 times 0 1, and so on, you will observe that after decimal, numbers are not being repeated. Okay, 0 1, then 001, then 0001, pattern is being repeated but not the period. Okay, so it's not like you are getting 0 1 here also you should get 0 1, but you are getting 001. After that you are getting 0001. So you can see that the numbers are not being repeated after decimal. Okay, so these types of decimal form are known as non-terminating non-repeating decimal form. Okay, if you convert root 2, you have already encountered root 2, root 3, root 5. If you convert them into decimal form, you will find out that these also never terminates. Okay, so root 2, root 3, root 5, these are also known as non-terminating non-repeating decimal form, because if you write them in the decimal form, you will find out that their decimal also never terminates. So non-terminate and never terminates and does not repeat as well. So yes, all these numbers are also non-terminating non-repeating decimal form. Okay, also pi, if you convert pi into, if you know the value of pi, you have known that the value of pi is 3.14, and you will say that since this is 3.14 and there is no 3 dots after this, it means it should be terminating. Okay, when you write terminating decimal, you do not write three dots because the decimal has terminated. But when you write non-terminating decimal numbers, you write three dots at the end because the division has not terminated. Okay, so here you see that since you have learned that pi is equals to 3.14 and not three dots, so you will say that 3.14, so pi is a terminating decimal form. But let me tell you that pi is not terminating, it's non-terminating non-repeating decimal form. Okay, you have they have not told you because it can get confusing in smaller classes, but in this class you will have to know that, in class 9th you will have to know that pi is also non-terminating non-repeating decimal form. Okay, so these are the examples of non-terminating non-repeating decimal form. So I hope this is clear to you all. So why did I explain all this to you? The reason behind for this was I wanted to tell you that what type of decimal numbers was rational numbers and what type of decimal numbers was not a rational numbers. Okay, so I told you that those decimal numbers that can be converted into p by q form are rational numbers. Okay, where p and q are integer and q should not be equal to 0. Now you can see that both terminating and non-terminating but repeating decimal were obtained from a fraction. Okay, I obtained terminating decimal from a fraction number and also non-terminating but repeating decimal from a fraction number. So yeah, again I can convert a non-terminating but repeating decimal to a fraction form, similarly a terminating decimal to a fraction form. For example, let's do a drill as well. So if I ask you to convert, so if I ask you to convert 1.5 back to p by q form, this is a decimal form and I ask you to convert into p by q form. So what you will do, you will just write 15 by 10 and again 15, 5 times 3 and 5 times 2 is 10, so 3 by 2, and you just saw that 3 by 2 was equal to 1.5. When I divided 3 by 2, I get 1.5. So you can convert 1.5 back to p by q form. Similarly, you can convert 0.333 to this form again. This is not that simple, but we can do it. And how can we convert non-terminating but repeating decimal form to p by q form? You will have to learn that. Okay, this is little bit different. We cannot use this approach, the above approach, to convert this non-terminating but repeating decimal form to p by q form. Okay, so this you will learn in class 9th only. Okay, I will make a separate video where I will explain how to convert non-terminating but repeating decimal form to p by q form. Okay, but the last one, non-terminating non-repeating decimal form, there is no way we can convert non-terminating non-repeating decimal form to p by q form, and that is why these two are rational when we have a terminating decimal, and when we have a non-terminating but repeating decimal, we say that both of those numbers are rational number. But when we have non-terminating non-repeating decimal form, we do not say that that is a rational number. In fact, this is not a rational number. Okay, so when you have a non-terminating non-repeating decimal form, so you say that that is not a rational number. Okay, so this is what I have written here. Okay, now only terminating and non-terminating but repeating decimals can be converted to fraction form, and hence terminating and non-terminating but repeating decimals are also known as rational numbers. So this was a brief introduction about rational number. Okay, now let's see what we have learned so far. Okay, so if I represent everything that we have learned so far on a number line. Okay, so if I have a number line 0 1 2 3 4 and यहाँ पे positive infinity, negative infinity, -1, -2, -3, -4. Okay, this is 1 2 3 4. Okay, now we know that 0 1 2 3 1 2 3 4 are natural number. If we include 0, then we get whole number, and if we include all the negative integers, then we get what? Integers. Okay, so until here we have integers. Okay, now what about the numbers that lie between 1 and 2? Okay, so between 0 and 1 there were numbers between 0 and 1, 1 and 2. So what about those numbers? So yeah, when we read about rational numbers, those numbers were also covered. So the few numbers that lie between 0 and 1 were also covered, like decimal numbers and fraction numbers. Okay, so the numbers that lie between 0 and 1, 1 and 2, 3 and 4, and similarly -2 and -1, -3 and -2, all those numbers are what? Fraction number or decimal numbers. Okay, so we covered them as well when we studied about rational number. So now you will think that all the numbers are covered, our number line is complete, our number line is continuous. Now we do not need any other type of number because we have all the numbers on the number line. We have the natural numbers, whole numbers, integers, and rational numbers, and this means that our number line is complete. But student, let me tell you that there are other numbers as well on this number line that does not comes under rational numbers. You see, all the natural numbers, whole numbers, integers comes under rational numbers, but there are certain decimal numbers, in fact these numbers, these non-terminating, non-repeating decimal numbers, which lie on the number line but they does not come under rational numbers. So we have to study about them as well, okay, and then only our number line will become continuous. Our knowledge of numbers will be complete only when we learn about non-terminating, non-repeating decimal numbers. So now we will learn about non-terminating, non-repeating decimal numbers, okay, and those numbers are known as irrational number. So any number which is not rational is an irrational number. This is the first point that you should note about it. So if a number is not a rational number, then it means it is an irrational number. Only if it is real. If you have a real number, then it is either going to be an rational number or an irrational number. Okay. So now we will learn about irrational numbers. So any number that cannot be represented in the form of p by q, where p and q are integers and q is equals to 0, are known as irrational numbers. So the define of irrational number is exactly opposite of that rational number, okay? And irrational numbers have non-terminating, non-repeating decimal form, and this I already explained to you that those numbers which have non-terminating, non-repeating decimal forms are known as irrational numbers, okay. Now the few examples of irrational numbers are here: root 2, root 3, root 7, pi, and this particular number, that is 1.10, 100, 100, and so on. All these numbers are irrational numbers, okay. So this is it about irrational numbers, okay. This much you need to know. And now let's do a small drill where we need to recognize the types of number, okay. So on the left side we have the numbers, okay, various types of numbers, and on the right side you will see I have written natural number, whole, integer, rational, irrational. Now we will look at the number on the left, and if like this particular number 10609, if this particular number belongs to the natural number category, then we will write a tick mark here, yes, because this number belongs to the natural number category, okay. Again, is this a whole number? So yes, this is also a whole number. What about, is this an integer? So yes, this is an integer. You know that any number which is a natural number or a whole number is also a integer, okay. And why is this a natural number? Because you know that natural number starts from 1 and goes up to infinity, and between these range it will lie somewhere, okay. 10,609, okay. So 10,609 will lie on the number line somewhere between 1 to infinity, and that's why it is also a natural number, okay. Now it is also a whole number. Since it is a natural number, it is always going to be a whole number and always going to be an integer, and all natural numbers are also rational numbers. So yeah, this is also a rational numbers. So any number which is a natural number will always be a whole number, will always be an integer, and will always be a rational number, and it will never be an irrational number, because any number which is a rational number is never an irrational number, okay. Again, 3 by 7, is 3 by 7 a natural number? You know that any number which is a natural number do not includes fraction and decimal forms, okay. So this is not a natural number, okay. Now again, this is not a whole number, because again whole number do not include fractions and decimal numbers. Integer also do not include fractions and decimal numbers. What about rational numbers? So we know that any number that can be represented in the form of p by q, where p and q should be integer and q should not be equal to 0, are rational numbers. So you can see that this 3 by 7 is written in the form of p by q, and both p and q are integers. P and q are 3 and 7, and 3 and 7 are integers, and 7 is not equal to 0. So this is a rational number, whereas it is not an irrational number, okay. 6 by 2 is also not a natural number. Now some of you may have a doubt that, sir, we can write 6 by 2 is equals to 3, and this, since this 3 is a natural number, so 6 by 2 is also a natural number. But let me tell you that this is not the case here. 6 by 2 is a fraction, okay, and 6 by 2 is equivalent to 3, not equal to 3. It is equivalent. You must have learnt about equivalent and equal. So equivalent is the value is equal but not the class. So 6 by 2 belongs to fraction, but 3 belongs to natural number, okay. So 6 by 2 is not a natural number, okay. 3 is a natural number. So 6 by 2 itself is not a natural number. Similarly, it's not a whole number as well, not integer as well, but it is a rational number because p by q form, and again p and q, that is 6 and 2 is are integers, and 2 is not equal to 0, but not a irrational number. Okay, 9.6. 9.6, you can clearly see that I told you that when you have a decimal number and you can't see three dots behind the decimal numbers, last decimal digit, it means that decimal number is a terminating decimal form. So this 9.6 is a terminating decimal form, and we know that terminating decimal forms are a rational number, whereas it is not natural, not whole, not integer, because all of these three does not include decimal numbers. And this is not an irrational number because we know that any number which is rational is not an irrational. What about 0? 0 is not a natural number. You know that counting does not start with 0. Okay, you always start counting from 1 2 3 4 5 6 7 8. If I ask you to count number of fingers in your hand, will you start counting by 0 0 1 2 3? No, you will start counting by 1 2 3 4 5 6. Okay, now so so 0 does not comes under counting number. Okay, so 0 is not a natural number. What about whole number? So 0 is a whole number, 0 is an integer, 0 is a rational number because again I can write 0 by 1. Okay, and both 0 and 1 are integers, and denominator should not be equal to 0. Numerator could be 0, but denominator is what? 1. So yeah, this is a rational number. Okay, so I hope this is clear to you. 0 is a rational number because I can write 0 by 1, and since 1 is not equal to 0, so yes, this is a rational number. What about irrational? Anything which is a rational, not an irrational. What about -7? Not a natural number, not a whole number, but an integer, also a rational number because I can write -7 by 1. Okay, now so yeah, this is a rational number, whereas it is not an irrational number. What about 1.6767 dot dot dot? So now you can see that three dots after the last decimal, after the last digit after decimal. Okay, so this means that this is a non-terminating decimal form. But non-terminating, in non-terminating we have two decimal, that is non-terminating but repeating, and non-terminating non-repeating. So what about this decimal number? So this is non-terminating but repeating because you can see that 6 7 is being repeated, so it means this is non-terminating but repeating. And I told you that any decimal number which is non-terminating but repeating, it means it is a rational number, not an integer, not a whole number, not a natural number, because you know that decimal number does not comes under these three. Okay, and it is never going to be an irrational number because it is a rational number. What about 3.8 bar? It is read as 3.8 bar. So what does this bar signify? See, another way of representing non-terminating but repeating decimal is by putting a bar over the number which is being repeated. Okay, so as you can see that here I have written 1.6767 then triple dot. I can also write it as 1.67 bar. This will also mean that this is a non-terminating but repeating decimal form, whereas 67 is being repeated. Anything which is under the bar is being repeated. Okay, so again 3.8 bar is also a non-terminating but repeating decimal form where the 8 is being repeated. Okay, so this is a rational number but not an integer, not a whole number, not a natural number. I don't need to tell you why because I have told you multiple times. Okay, and this is never going to be an irrational number. Okay, now because anything which is rational is not an irrational. What about root 7? Root 7 not a natural number, not a whole number, not an integer, not a rational number, but it is an irrational number. So you can see that anything which was rational was never an irrational, but anything which is not an irrational number is an irrational number. So this is why I am doing it, because you should be clear that you should be clear about the numbers. Okay, because numbers is the basic fundamental of mathematics, and if you are not clear about the numbers, then how can you suppose to do mathematics? Okay, now so what about root 2 by 1? Now some of you may think that yes, root 2 by 1 is in the form of p by q, and since it is in the form of p by q, it should be a rational number. But students, this is where you make mistake. Let me tell you what was the definition of a rational number. I want you to remember. So the decimal of rational number was that any number that can be represented in the form of p by q, but it was not this much only. Okay, there were few words, few other words as well. So any number that can be represented in the form of p by q, where p and q should be integers. So is root 2 an integer? P is what? Root 2. Is root 2 an integer? No, root 2 is not an integer. So it means the decimal is not fulfilled. So definition, sorry, not decimal. Definition is of rational number is not fulfilled here. And since decimal definition of rational number is not fulfilled by root 2 by 1, we can say that it is not a rational number. And if it is not a rational, then it means it is an irrational number. Okay, and this is never going to be an integer, not a whole number, not a natural number, because root 2 does not comes under any of these. Okay, and this is also a fraction, and fraction does not comes under integer also. Okay, what about pi? Pi, I already told you that pi is an irrational number. Okay, not a rational, and if not a rational, then never can it can be an integer, whole number, or natural number. Okay, what about 1.01001 dot dot dot? So this is a non-terminating, non-repeating decimal form. Okay, so this is going to be a irrational number, but not rational, not integer, not whole, not natural. What about minus root 3 by minus 5? Minus root 3 by root 5. Again, you will say that this is in the form of p by q, and this should be a rational. But again, I want to tell you that root 3 is not an integer and root 5 is not an integer. And since p and q should be an integer, then only the number is going to be a rational number. So this means that this is not a rational. It means it is an irrational. Okay, now let's do one more example. What if I ask you 1 by 0? Is 1 by 0 a rational number? So 1 by 0 is neither rational nor irrational. Okay, so 1 by 0 is not defined. 1 by 0 is not defined. Okay, division by 0 is not possible. Okay, any number cannot be divided by 0. And what about 0 by any number? So yeah, this is possible. 0 by any number is equals to 0. Okay, so you should be clear about these two. Okay, any number divided by 0 is not defined, and 0 divided by any number is equals to 0. Okay, so now I am going to give a final conclusion of everything that I have covered in this video. Okay, so if I have to write everything in just few words, I can say that all the numbers that are real will either be rational or irrational. Okay, so if a number is a real number, then it will either be a rational number or an irrational number. Okay, now rational number, out of rational numbers, few are integers. Okay, so there are large number of infinitely many numbers which are rational numbers. Okay, out of those there will be infinitely many numbers which are integers. Okay, and out of those, out of integers, we have, out of some numbers are whole numbers, and in whole number we have natural number. Okay, so if I make a number line, and if here is 0, so this number line will include all the rational and irrational numbers. Okay, so and if a number is rational, then it could be an integer as well. Okay, so if the number is not a decimal number or a fraction number, then it means it is going to be an integer. Okay, and out of integers, the positive integers including 0 are known as whole number, and positive integers are known as natural number. Okay, so this is the final conclusion of everything that we studied today, and with this I would like to end this video. And if you like this, if you like my content, then please like this video and share it with your friends, and you can subscribe to our channel as well. I will keep bringing content like this for you people. So thank you very much.